I am so glad you're here for another episode of Mechanism Monday. In last week's video, I asked if you could solve the mechanism for this chemical transformation. So if you haven't had a chance, pause the video now and try it independently. And make sure you stick around to the end because I'll give you another mechanism to solve for next week's video. In this very unique reaction, I think most people can intuitively recognize that using this furan-diene and given the structure of the final product likely means that there's a Diels-Alder reaction happening. However, notice that we're losing some pretty significant functional groups as a part of this reaction. And in fact, the first step is going to be to liberate those. So the first step in this reaction can actually help us produce a very reactive intermediate that you may or may not have seen before, and that's called benzene. In order to do that, we first need to liberate carbon dioxide. So this lone pair of electrons can come down, which is going to allow us to liberate the carbon dioxide from this reaction. And also notice that once these electrons move here, this is going to generate 5 bonds at carbon, which is how we actually liberate nitrogen as a gas additionally. And notice that that means that we're forming a second pi bond as a part of this benzene structure. And anytime you have that second pi bond here, this is called benzene. And it is an incredibly reactive intermediate that is useful in a variety of organic transformations. And the driving force for this is going to be the fact that you're liberating nitrogen and CO2 as a gas. So if this reaction is performed in an open flask, for example, the nitrogen and the CO2 gas is going to leave, which according to Le Chatelier's principle is going to drive this reaction forward. And what we've done here is we've created an incredibly reactive intermediate called benzene, which is going to act as a great dienophile for subsequent Diels-Alder reactions. So once we've generated benzene, we can bring in the furan, which has the diene portion of our Diels-Alder reaction, where the pi electrons here are going to come to this carbon. These pi electrons will go to this carbon, and these pi electrons will move to being between these two carbon bonds. And that actually is the last step in this transformation and how you form this cyclic fused ring system, where you have a benzene portion, you have the fused ring with the bridged oxygen at the top of this ring. And ultimately, the driving force for this is going to be the liberation of CO2 and nitrogen gas to generate the benzene intermediate. If you enjoyed this week's video, make sure to give it a thumbs up down below. And for next week's video, I'd love to see if you could figure out the mechanism for this chemical transformation. Make sure that you're subscribed to the channel so that you never miss out on another mechanism. I'll see you next Monday.